Welcome back to Unit 3, Chapter 6, Section 4. We're going to talk about inverse functions today. We'll try to find them. Here's our goal, finding inverse functions. That's the main goal, short and sweet today. And we should have the target in your notes so I can check it tomorrow, along with everything else we're covering hereafter. Okay, here's the right slide. Inverse functions. Inverse functions are when we switch the input and output of a function and then solve for y. So inverse functions can be found following these two basic steps. Find an equation for the inverse. Switch x and y and then solve for y. Those are the steps. Now, you're saying, I don't see a y here, Mr. Kuhn. I see a f of x. And here are some extra examples. If you would like to try those on your own, you can. Okay? But we're going to, what does f of x really mean? F of x means y. So first off, I'm going to switch this to y equals 7x. Okay, the steps say switch x and y. So I'm going to, x and y are going to switch places. Good, I just wrote the inverse equation, right? No, we have to solve this for x. Excuse me, for y. We have to get y by itself. So we undo, we use order of operations. There's something multiplying by y, something subtracting it. We undo the subtraction first. X plus 4, those are not like terms, so I just write x plus 4 equals 7y. And then finally, 7's in front of y, it's multiplying, you undo multiplication by dividing. And we end up with y equals x plus 4 over 7, or y equals x, or 1/7 x. Check that a little bit neater here. 1/7 x plus 4/7. And then, of course, we want this in function notation. So the best fancy way to write it would be the inverse of f, or f to the -1, equals 1/7 x plus 4/7. Or the inverse of f, if you left it without separating them, x plus 4 divided by 7. Okay, so that's how you find inverses. What is it going to look like if we were to graph these functions? That you all asked. 7x plus, or minus 4, excuse me. And then we're going to graph alpha y equals, let's put a fraction in here. What was our answer? X plus 4 divided by 7. And I'm going to go ahead and delete this 0. It's loading out over here on the side. Let's graph these and see what we get. Okay, and this is the picture of it. F of x and the inverse. The definition of an inverse is that when you take the line y equals x, which is approximately that line, y equals x, the diagonal that runs from the origin up and to the right and kind of splits quadrant 1 and quadrant 3 at 45-degree angles. That's a y equals x. You can reflect your inverses over that line. And if you look, I could flip the inverse and the original function. They could reflect over that line and flip onto each other. That's one way to test to see if you actually found the correct equation of an inverse function. I'm going to leave these other examples for you to do here. You can try those if you'd like. Otherwise, we'll have more examples in class tomorrow. Okay, inverse of a power function. It's the same process, same principle. We switch x and y, and remember f of x is really just y. So I'm going to skip ahead to x equals 1/4 times y to the 3rd plus 3. I took out f of x, I put in y. So we just solved this thing for y, subtract 3 from both sides. Divide by 1/4, or instead of dividing by 1/4, We multiply both sides by 4. It cancels the 1/4 out. And I get 4x minus 3. 4x minus 12. It's got to multiply by both the x and the 3. Equals y to the third. How do we get rid of a cube? Well, we cube root both sides. Back in chapter 5. So we cube root both sides. We get the inverse of f is the cube root of 4x minus 12. Okay, once again, we graph these two functions. Y equals, we go to y equals, and we graph 1/4 x to the third plus 3, and we graph our resulting function, which is the cube root, which is 4 of 4x minus 12. Graph them. Here's our first function. Here's our inverse function. And notice when you put them together, it's like they make a base. Kind of cool. But you can draw that imaginary y equals x line in these graphs. They reflect right over that line onto each other. Okay? So that's where I would do to check it, make sure you did it correctly. Does it reflect over that y equals x line, that diagonal line? Because if you flipped quadrant 1 through the origin, if you bent it so the y-axis and the x-axis lay on each other, does it reflect over that line? Okay, the horizontal line test. Horizontal line test, similar to the vertical line test. Vertical line test let us know if a relation is a function not based upon its graph. If a vertical line crossed any graph in one place, then it was whenever you drew a vertical line on the graph, then it was a function. If you drew a vertical line and it crossed the graph in more than one place, then it's not a function. Well, the horizontal line test kind of goes along those lines, but it tests to see if the inverse of a function is also a function. So I took the liberty of already graphing these on the graphing calculator. Okay, determine whether it's a function or not. I just put these two functions into y equals, and it doesn't matter where I draw a vertical line. Excuse me, horizontal line. Let's look at the first example, 1/2 x plus 5. I can move that line up. I can move it down. It only crosses the graph, which is that diagonal line, in one spot at a time. And if I extended the line, it would keep going in one spot. So I can slide that line up and down the graph, and it only crosses once. So the inverse of f is a function based on the horizontal line test. How about this one? Absolute value function. If you want to do an absolute value function, you hit math and go over the number. It says ABS. You click on that. It lets you put the graph of that absolute value bar in. Let's take our line. Let's move it down here. And right off the bat, I can see it crosses more than one spot multiple times. The only spot it actually passes is right at the vertex of it. But it's only got to fail one time. Doesn't matter how many times it passes. If it fails one time, it's a pretty harsh test, then the inverse is not a function. So for this one, the inverse of f is not a function because of the vertical line, the horizontal line test. So that's how you can use the horizontal line test. We'll get more practice with that tomorrow. So, did we address our goal? I think we did find the inverse, finding inverse functions. We also added that a little bit with the horizontal line test, what that's all about, and how we can use that test to see if inverses are indeed functions. Have all the notes ready to go, and we'll see you tomorrow to work in class.